Hello. I think we're connected now. Can you hear me? Do you see
Yeah,
that?
yeah.
Okay,
Mhm.
great.
Yes.
Thanks. So check. Okay. There. Okay. So let's see. First thing, I finally got the homework assignment up last night. So let's look at the homework assignment. Okay. So it's due February 9th. That is a week from Tuesday. Okay. So it's due not quite 2 weeks. It's due a week from Tuesday. Okay. So, and if you go here, it's on this page here. Of course, it starts with you need to download the zip file. So I'll download that, show you what's in it. And okay, the assignment is for you to write 4 little programs. Okay, so the assignment, you have to read this real carefully. The assignment is to write 4 small programs. Okay, and in here, let me start up Dr. Java. In the folder are 4 programs, this one, this one, this one, this one. And they're kind of started for you. Like this one looks like this so far. It does this much, and you have to add more code down here. These programs are meant to do little conversions. See, this one converts feet and inches to centimeters. Okay, so now if these are all compiled, they're not completed, but you can compile it and you can run it. And what it does so far is it asks you to see, it gets to line line 14 prints out homework 2, part 1. Line 15 prints out convert feet and inches to centimeters. Then line 18 prints out enter the number of feet. That's here. So it's asking for the number of feet. I'll say 3. Okay. Then it reads in the variable feet. So now feet is 3. And it says enter the number of inches. I'll say 5. Okay, then it's going to read in number of inches to 5, but then the program ends. Okay, that doesn't do anything else. Okay, now what you have to do is take feet and inches and compute how many centimeters that is. Yeah. So you have to convert. You have to do a little bit of. You have 2 variables here, and you need to create another variable called centimeters and do a little formula that converts the number of feet and inches here to how many centimeters that is. And then you have to print out the answer. Then here are some pictures of what your answer should look like. So for example, if the user typed in 5 feet and 10 inches, you should print out 5 feet and 10 inches is 177.8 centimeters. Oh, centimeters is going to be a double variable, not an int. The number of feet and inches is an integer amount, an integer number of feet. So you can't, this program doesn't let you type in 1.5 feet. Okay, you type in an integer number of feet and an integer number of integers. So it doesn't allow for 2.5 integers. It's just integer number of feet, integer number of integers. But the centimeters will be a double because the conversion is 2.54 centimeters per inch. Like it tells you here in the homework assignment. The conversion factor is 2. So the conversion factor is itself a double. Okay, and you have to have a variable that holds that 2.54 centimeters to inch. Okay, so here is one example of what the output should look like. Here's another example of what it would look like. If somebody enters number of feet and they enter 0, number of inches is 1, then 0 feet and 1 inch is 2.54 centimeters. Okay, and here's a third example. Now, these pictures do 2 things. They show you what you print out. You should print out a message just like that. And they also give you something you can test your program with. You should make sure that if your program works right, 100 feet and 200 inches is going to be 3,556.0 centimeters. Okay. All right. So that's the first one. Okay, so you have to complete this. You have to, I put the part in here that reads the prompts from the user, and you have to do the arithmetic part. Okay, part 2 is going to convert inches to feet and inches. Okay, now here you compile this, it runs. It doesn't do very much yet. This one does a little bit less. Okay, notice it printed out homework 2, part 2, convert inches to feet and inches. Then it prompted enter the number of inches, but then it stopped there. So you have to add. It's like here I gave you the code that did, see, the scanner was created here. We use the scanner to read from the users what they type. Well, in this one, you have to write the code that does the scanner in for the number of inches, and then you have to figure out, well, here's the examples. For example, 40 inches is 3 feet and 4 inches. There are 3 feet and 4 inches in 40 inches. Okay, so you have to do a calculation that computes how many feet and inches there are in a given number of inches. Okay, and there's several examples here. 1,234 inches is 102 feet and 10 inches. Okay, 10 inches is 0 feet and 10 inches. Okay, so there's examples. Now, if you think about this one, what this is really at, like the number of inches is 40. That's 3 feet and 40 inches. Remember, there's 12 inches to a foot. So this is really asking how many times does 12 fit in 40? Okay, if you take the number 12, 1 12 is 12, 2 12s is 24, 3 12s is 36. You can't put any more 12s into 40. So 3 12s fit into 40. Now 3 times 12 is 36. That leaves you 4 left over. That's what we mean by what are called integer division, quotient, and remainder. So what that's saying is, let me type it in a, well, that's saying that the fraction 12 divided by, I can't type I mean, I'm going to do it here as like I'm writing a fraction. 12, I'm sorry, 40 divided 40 divided by 12 is, well, there's 3 12s in 40 with remainder 4. See, 12 divided by 40 is 3 with remainder 4. We write that in Java. We write something like this in Java using, we write it this way. In Java, 40 divided by 12. In Java, this division means quotient. Okay. If you put a decimal place in here and make these doubles, then 40 divided by 12 gives you what your calculator gives you. 40 divided by 12 would be, well, let me see, what is 40 divided by 12 if you do it on a calculator? Google's a calculator. 40 divided by 12 is, I did mistype something again. 40 divided by 12 is 3.33333. Okay. See, Google does the regular kind of division, but Java doesn't. When you give Java integers with no decimal place, it doesn't do this kind of division. And I can show you that over here in the interactions pane over here in Java. I can go, let me reset the interactions pane. Okay. Over here, now if I type 3 times 2, tells me 6. See, the interactions pane is a calculator. One of the nice things you can do with the interaction pane is a calculator. What's 40 divided by 12? 3. See, not 3.333. What's, now, when you divide, oh, I typed the wrong thing again. 40 divided by 12 See, is 3. Now, it doesn't matter. 40 divided by 12 is 3. 40 divided by 13 is 3. There's 3 13s in 40 also. There's 3 12s. Okay. 40 divided by 11 is also 3. There's 3 11s. Okay. Now, so 40 divided by 12 is 3. But 40, what's the remainder? The remainder is this symbol. When you put as many 12s as you can into 40, now actually it's a little bit easier to read this if I put spaces around it. If you put 3 12s into 40, you get 4 left over, because 3 times 12 is 36, and you get 4 left over. So this is called quotient, and this is called remainder. Okay. And in the book, they talk about that. So 40 divided by 12. Now that means if they give me 40 inches, this is what you have. This is the calculation you have to do in your little bit of code. You have to do the quotient and remainder calculation to say the user typed in 40. 40 divided by 40 quotient 12 is that many feet. 40 remainder 12 is that many inches. So you have to do those two. Essentially, you have to do those 2 lines of code. Okay. So for the part 2, you have to put down here the 2 lines of code to do the quotient and remainder, to find out how many feet are in that many inches and how many inches are left over after you do that many feet. Then you have to print out this message. You have to print out that message, just the way it's printed out here. Your program should end up looking just like this. So you should print the message exactly the same way I'm printing it here. Part of the goal of the assignment is that you should figure out how to do. So you have to get the answer 3 and 4 in the middle of your output. See, you have to write your output's going to have to say there are. Then 3 is going to be a variable that you calculated, feet, and then there'll be a variable that you calculated, inches in. Then this will be the variable that you read in. So this will be a variable you calculated. That'll be a variable you calculated. And that's the variable that you read in. So you have to print out there are something feet and something inches in something inches. So you have to look in the book and see how do you get that kind of output. Okay. All right. So that's number 2. Okay. That's then number 3 is a little bit. Okay. Number 3 is similar to number 2, just a little bit harder. Number 3 says if you give me it converts ounces to how many gallons, quarts, cups, and ounces are left over. How many like if I have 150 ounces, how many whole gallons is that? Then out of what's left, or how many whole quarts go into what's left over after you figure out how many gallons there are. Then after you figure out how many gallons and quarts there are, what's left over, how many cups are in it. So for example, if you have 1,234 ounces, that's 9 gallons. Then after you fill up 9 gallons, you could fill up 2 quarts. Then after you fill up 2 quarts, you could fill up 2 cups, and you would then have 2 ounces left over. That's doing quotient remainder several times. There's 128 ounces in a gallon. So you have to divide this number. Yes, you have to ask how many 128s go into this number. That's how many gallons there are. Then you do the remainder, and that's how many ounces are left over. But then you have to say how many quarts go into the remainder, or the remainder from dividing by this one. So you'll do, to get the gallons, you'll do a quotient. That'll be this first answer. Then for the gallons, you get a remainder. But then you use that remainder to compute this answer. You'll take the remainder from gallons and do the quotient with, I think 32 ounces in a quart. And then you'll get another quotient, which is how many quarts there are, and you'll get another remainder. Then you use that next remainder and divide it by 8 to figure out how many cups were in that remainder. Then you'll take that and divide it by 8 again with the quotient. You'll do the remainder with the quotient. That's how many ounces are left over. So you have to do quotient remainder 3 times. Once for gallons, once for quarts, once for cups. Okay, so this one's a little bit trickier, but you're going to do quotient and remainder 3 times. One for gallon, one for quarts. With gallons, I think it's 128. There's 128 ounces per gallon. For quarts, it's 32. You divide by 32. And for cups, you divide by 8. Okay. And there's a couple examples of the output. Okay. If there are 134 ounces, that's just a little over a gallon. So 134 ounces, there are 1 gallon, no quarts, no cups, and 6 ounces left over. So it'd be one, and you have to write all that out. So you'll say, you have to, again, you have to write the output. Notice that this will be, that number there is the one you read in something ounces, there are something gallons, something quarts, and something cups with something ounces left over. Each number is a variable in your program. So you'll need 1, 2, 3, 4, 5 variables in your program, and they're all integers. In this case, everything's an integer, okay? And the program comes with only the prompt this time. See, only the okay, if you run this, oops, oh, I can't compile this one because I have to lose my file over here. So I have to go back over here and lose this guy to be able to, let's see, no, actually, I think I can compile. Let's see if I can. No, it won't let me compile that one. Oh, let me just go ahead and save that. Boy, that's little type, quotient and remainder. Okay, so see if, now that's not going to, I can't, now I can't go back here and compile this yet, because what Dr. Java does is it compiles everything you have open. Whenever you compile one thing, it compiles everything. And that's not a legitimate Java program. So I have to close it. So now I can compile 3, but it doesn't do anything. So it compiles, except it will print out the homework 2, part 3, convert ounces to gallons, cups, and quarts. So it gives you this first part. Then you have to, now the scanner is already created for you. So now you have to prompt the user, use the scanner to read in their number. So you need the code to prompt the user, use the scanner to read what they type, then do three steps of quotient remainder, quotient remainder, quotient remainder to get the gallons, quarts, cups, and ounces. Okay, so that's the third example. So the third example is just like a slightly harder version of the second one. Okay, the same idea for this one is this one, using quotient and remainder. Okay, and then the fourth one, okay, fourth one is you have to convert gallons, quarts, and ounces to the equivalent liters. So if somebody says, I have so many gallons, so many quarts, and so many ounces of liquid, how many liters do I have altogether? And here's the examples of what your program should look like when it runs. Okay. For example, if somebody has 2 gallons, 3 quarts, and 4 ounces, that gives, now notice that this is a decimal number. The liters will be, these are ints. You should read in an integer number of gallons, an integer number of quarts, and an integer number of ounces. And then the output will be in liters, but it's a decimal number. Okay. And here's another example. 0 gallons plus 1 quart and 8. Oh, let me show you something about Java. Let me go back to the interactions pane. Normally in Java, if you do a double, see how many decimal places it has? That decimal place has, that number was written with a lot of decimal places. Over here, I asked you in the homework assignment to only print 4 decimal places. There's a way to tell Java to print doubles without all their decimal places, to essentially round it to fewer number of decimal places. So another example is 2 divided by 3. Oh, notice I have to put the point zeros in there, because if I don't put the point zeros in there, 2 divided by 3 is 0. How many 3's go into 2? Well, you can't fit 3 into 2. So there's 0 3's in 2, okay? So if I want to do calculator-like division, I got to put a decimal place in those numbers, okay? 0.66666, okay? But what if I don't, if I don't want to print that many decimal places, okay? Now, in the homework assignment, there are links to where you can read about some of these ideas. So, for example, here's a link to where the textbook talks about remainder. Okay, there's the feet and inches example. They do the feet and inches example right here in the book. So there's a little reminder. Yeah, that's essentially what your homework is doing. So there's a little reminder here of how you use quotient and remainder to figure out feet and inches. Okay, so there's a good hint about that's the number 2 one. Okay, so that's a link in the homework assignment. And then this other book also has some information about, well, the thing that I'm calling remainder is also called modulo. About half the world calls it remainder operator, and about half the world calls it the mod or the modulo operator. So if you're reading programming books or you're reading information on the internet, this remainder operator is often called mod or modulo. Okay, and it's the percent symbol. So here they give you a little explanation about it. Okay, so there's little explanations in the book about these things. Okay, and then here's where there's an explanation of formatting your output. See, here, instead of printing when you take 4/3, so if we go back over here to Dr. Java, now we can do it interactively in Dr. Java. 4.0 divided by 3.0, just like he's doing here, 4/3. Now I don't need to print it in the interactions pane. See, there's 1.33333. Okay. Okay. Now here he shows you a way to control how you print out. Okay. There's, instead of using print, you can also use something called printf. Now over here, I need to do that. I need to do system.out.printf. Print, the F there stands for print formatted. So it lets you format your output. It lets you control how output is done. So here's what I do. I create a special kind of string. And the special kind of, it's a little bit tricky. It's a bit weird, and it takes some getting used to. I'm writing something called a format string, and I write %.3 f close, okay, comma, then my number 4.0 divided by 3.0. Okay, what this is telling Java is to print the number with 3 decimal places. This is saying output the decimal number, F for floating point, but it means decimal number. Print the output number with 3 places after the decimal point. See, after the decimal point, there'll be 3 places. Okay. I got my 1.33. I'm not sure why. Let me put a semicolon over here. Okay. I needed a semicolon. Otherwise, Dr. Java gave me a weird answer. Notice I got my 1.33. Now, if I go back here and I say, oh, I want only 2 decimal places. There's my 2 decimal places. If I want only 1 decimal place, if I want 10 decimal places, there's 10 decimal places. If I ask for 100 decimal places, I won't get them. Well, actually, I do. But notice that it just makes up the last decimal places. The double only has 15 or 16 decimal places in it. So if I ask, the double has, I think it's about 16 decimal places in it. See? Now, if I try 17, I'll probably get a 0 at the end. See, it made up that 0 at the end. If I ask for 18 decimal places, it's now making up decimal places. It's just making them up. It's just adding zeros at the end. Numbers in Java have 16 decimal places. Okay, so you can ask for up to 16 you can ask for more decimal places, but they tend not to mean anything. Okay, so if you ask for more decimal places, it just makes them up. Okay, so there's a whole lot of made up zeros. Okay, all right. All right, so you read this thing here about formatting output, and it tells you how to, you have to use the printf command instead of print. Okay, okay. Now, there's that explanation, and here's another one on the internet. This is another one explains how to use printf, and it tells you a little bit more about printf. You only need to know as much as I showed you in this example. I mean, this example here shows you what you need. This one tells you a little bit more. And it also shows you that there's another way to get this to work. Okay. Oh, let me show you a trick here. Let me see if this works. Let me reset the console window. Okay, I'm going to print out, instead of printing a number with decimal places, I want to do something else. There's 3 decimal places. I want to print out the number 1000. Whoops. What? I think it didn't like, let me see. Oh, okay, yeah. I said print a double. That's what the F means. And I gave it an integer and it actually complained. This is one of the few places where integers aren't treated as doubles. Notice that if I actually had to give it a double, okay. Now, suppose I want to print the number 1 million. So that's 1, 2, 3 zeros, 1, 2, 3 zeros. There's the number 1 million. Okay, notice it's kind of hard to read. Okay, I'm allowed to do this to make my 1 million more readable. Oh, I'm not allowed to do this. I get an error. You can't put commas in your numbers in Java, but you can put underscores where the commas are. So that makes 1 million easier to read. Whoop. Oh, you can't do that in int, no, double x equal 1 underscore 0.0. Oh, Dr. Java doesn't let you do this, I guess. Let me show you. I'm not doing something wrong. Let me switch to the Java visualizer. I think this is just I think maybe just Dr. Java is a little too old. Double x equal 1 underscore 123 123.0 system.out.printf. Okay, I want to print. Now here's my format string. Percent. I want 3 decimal places of my double. And the double is x. Okay. Forgot the semicolon there. Okay. Notice that I was able to put underscore. See, I could write 1 million a better way than 100. But see, over here, it didn't put the underscores. And down here, it didn't put the underscores. It let me type them there to make my number easier to read, but it's not, the underscores aren't part of the number. The underscores aren't part of the number. Okay. Now, oh, okay, let me go back to that. I can't do anything about the fact that the underscores don't show up here, but I can get commas in my printf output. I can get printf to put commas in its output here. And the way you do that is you put a comma in this format string. That tells printf to use commas when it's printing out the number. See, now I get 1 million printed out real nicely. Okay. All right. So if you put it now in this over here in this one, see, he does that that example is right there. There's the comma that gives you output with commas in it. So there's an example in here of this is printing a number with 2 decimal places and commas to mark off the thousands places. Okay, so this is saying use commas to mark off the thousands and hundred thousands and millions places. Okay, now you need that in your homework assignment. Okay, so if we go back here, oh, and yeah, Dr. Java in the interactions pane doesn't seem to allow the underscore notation. Now it does. Let me go back here. So I can't use the underscore notation, but I can put the comma here. See, so that printed out 1 million nicely. Okay, and if I make the number 1 billion, see, it prints it out 1, 000, 000, 000, 000. Okay, so Dr. Java does not let me use the underscore notation, but it does allow you to use the comma in the format string so that you can print out a number with the nice commas. Okay, in your homework for in part 4, so here's an example. If there's 1,000 gallons, notice that I wrote 1,000 just 1000. I didn't put the comma in there. You cannot put the comma in your input number, and Dr. Java won't let you put the underscore in your input number either. So 1,000 has to be typed 100. 200 quarts, 300. No, but then the output says 3,000, 975.5722 liters. So you need to get that comma in the output. So you need to use the little comma in your format string to get the commas in the output number. And here's another example. Okay, notice that that's hard to read without the commas. You know, what is that number? Let's see, it's 1,234,567. So that's 1,234,567. 0 quarts, 0 ounces gives you, oh, now I didn't put the commas in this printout here, but the commas should be in this one here. It gives you 4,673,347.6075 liters. So you have to get the commas in your output number. In this output double, you need to have the commas. Okay, you don't have to have the, there's no, you won't have commas in the input number, but you have them in the output number. All right, so you have to look. So this homework assignment uses a lot of little things from the reading, from the book, but the web page for the homework assignment tries to make sure that to direct you to where you should be going. Okay, so in the homework assignment, you'll see a few links, and those links are telling you, well, first of all, it says that these are the sections of the book that the homework assignment uses. Chapter 2 and Chapter 3 from one of the books, and Section 1.3 and 1.4 from the other book. So that's stuff about variables and operators, creating variables in a program and creating and doing calculations on the variables, addition, subtraction, multiplication, division. So that's covered in these sections. Plus, that's where the quotient and remainder symbols are talked about. But then here it tells you, read those two specifically. And you need to be able to format your output. So read that one specifically about that. Okay. So use the screenshots that are in this folder to test your homework. When you write your code should make you should make sure that your code when somebody types in that, and that, you get the output that looks exactly like that. Okay? So your outputs should look just like this. These, your outputs should look like these. That's your goal, to get your program to work just like these. When you're done, you'll send me your finished version of this one, this one, this one, and this one. Don't send me all these screenshots. The homework assignment only asks you to turn in, see, it says just turn in your 4 files, those 4 files, turn in those 4 files, put your name in all of them, and don't send me back the screenshots. Okay? So that's the instructions. Okay? And it's due a week from Tuesday. Okay? And like with the other homework assignment, if you have any kind of questions, please, send me questions or come to office hours. Read this real carefully and look at what's given to you in here. Make sure you understand the parts that are given to you. Like you're given the beginning of each you're given a little bit more here, a little bit less here, a little bit less here, a little bit less here, but you're given the beginning of each program. You have to finish it so you can match these screenshots. Okay? Anybody got a question? A question about the homework assignment? No? Okay. Okay. Right. So let's go on and start talking about the next topic. Okay. Okay. So today we're supposed to talk about these sections, which yesterday we did this idea of methods. Now let me just kind of review real quick. Let's look at this one here, the last one we did. Okay. Remember that a method is a collection of code that you've given a name to. And you can also give the method input parameters like we did here. Here we gave the method input parameters. So the method is, now there's only one line of code in here, but it has 2 input parameters. Okay, we have 1, 2, 3, 4 methods here. The main method has to be there because that's the one that Java runs. Java runs this method to run your program. And then here I said, now run my method 6 lines, which is written up here. Remember, when you get to here, we say you call the method. You call the method. So you jump up here, you do those steps, but this method called that method. So you jumped up here, you start doing these steps. This method calls that method, and there's the arguments to fit in to the parameters. So the number 1 goes into this, and the number 42 goes into this, a lot like math functions do. So you're supposed to think of this a lot like, then this is where it was designed to look exactly like the math you learned in algebra and calculus. I mean, that was what motivated programmers to think of writing programs this way. So you're supposed to see the parentheses are just like when you write cosine of x or logarithm of x, you use parentheses. Okay, so the parentheses are meant to look just like math. Okay, now none of these functions, these methods here did not have any. Now main has a parameter we'll learn about later in the semester. Right now we're ignoring main's input parameters. Okay, so main has a parameter, but we don't know what it does yet. This one didn't have any parameters. This one didn't have any parameters. This one has 2 parameters. So when you call it, you have to feed it 2 things. A string, because that parameter is a string, and a integer, because that parameter is a integer. Okay, so you have this thing, unlike math functions, which don't have types, the thing that's different in a programming language is when you write a function, we call them methods. When you write a method, and you want inputs to the method, you have to say what kind of input they are. This thing needs an int, and this thing needs a string. Okay. All right. So that's what we talked about. And remember, when you visualize this, you have what's called the flow of execution, because what you do is your program starts down here at line 20, because that's where you start. You start at main. Then you call this method here called print line. So it does, now that's a method that we didn't write. That's a method that the people who designed Java wrote. So the Java visualizer doesn't show us happening, but this goes and executes code written by the Java people, the people who wrote Java. And it makes this there's a parameter to that method. This parameter gets printed on the output screen. Okay. So your program does that line. Then it does that line, but that line flows you up to here. You do that line, but that line calls you up to here. So you do that line. That line calls you up to here with the parameters. Then when that line was done, you went back to here. But then this one took you back to here. Then when that one was done, you went back to here. Then this one took you back to here. When this one was done, you went back to here, but now you're done. So that took you back to here, because that's how you got to there. There's a lot of mental calculations you have to keep in your head when you read these programs. Notice that this program is not read from top to bottom or from bottom up or anything like that. The program is read in what's called the flow of execution order. The program is read by saying, I start here and ask, what does this program do? It does this, but this takes me up to here. Now I have to start reading here. This does this, I have to start reading here. This does this, I have to start reading here. Then I go back and read 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 here. And then I go back. Oh, this is done. And I go back and read here, but that sends me back to here. Now, that's how you read a program. That's what you have to learn, this flow of execution. And that's what the Java Visualizer is designed to help you with. It shows me all these little steps. So remember, I can watch it fast motion by taking this slider. Yeah, I can watch all that bouncing around with the slider. So I mean, I'm not sure that's useful. I'm not really sure why they put the slider in there. It doesn't seem to me to be especially useful. The only thing it's good for is if you want to jump to the middle of the program, you can kind of like get to the middle. See, then you go start stepping. I think that may be what the slider was. So you could, if you wanted to jump into about the middle of a program, you could slide yourself to about the middle. Okay. But at the beginning, okay, programs, okay, let me start again. Programs start. Well, actually, this program had an extra variable that was outside of the functions. So it actually starts by saying, oh, we have to figure out what y is. So this one actually started by saying, well, we have to say what y is. Y is 1 million. And then y is used over here. Okay. Remember, that was like the idea from math. When you have a formula like f of x is m times x plus b, that's what we call the linear equation. Usually the b and the m aren't from the function, they're somewhere else. Usually you would say m is 5 and b is 3. Then this is 5x plus 3. Okay. We use a symbol to represent the slope of the line and a symbol to represent the y-intercept of the line, but you have to decide what they are ahead of time. Then you could graph this function on your calculator. So in your calculator, you could do exactly this. You could say m is 5, b is 3, f of x is mx plus b, and then graph it. If you don't tell the graphing calculator what m and b are, and you just try to graph that, you'll get an error message saying, I don't know what m is and I don't know what b is. You'll get an error message. So we have the same kind of idea here. We've got like a formula that refers to y, and that y is this one outside of the method. See, this x is the x inside of the method, but this y is the y outside the method. Just like this x is the x in the function, but the m is the m outside the function, and the b is the b outside the function. Okay? All right. So if you do f of 3 here, that means 5 times 3 plus 3. Well, let me change the number so I don't have so many 3's. Okay. This means 5 times 5 times 4 plus 3. So notice the m came from up there. The x came from down there. The b came from up there. Same, that's how programs work too. If I follow this with something like, I decided I don't like 5 for m, so I'm going to say m is 6. Then I could redo f of 4, and I get a different answer. This f of 4 is now different than that f of 4, because this f of 4 says you go up there, f of 4, you go 4 times m, but now m is changed to 6. So that's 6 times 4 plus b. So that's how math books work. Math books would say m is this, b is this. Here's my formula. Use it. Change what m is. Use the formula again. Use the function again, but now m has this thing. So programs are like that too. Okay. Now we didn't change the y in this program. See here, I'm changing the m. That's the thing that's outside the formula. I'm changing the m. I could do that here. I could change what y is. Oh no, actually I did it here. There's a change in y. So you could change y somewhere in your program, and then eventually when you get back up here, you use the different y. So if we visualize this execution, we start with saying what y is. Then the next thing we do is go into main. Okay. So if we have an outside variable like this, we start with saying that's what, y, see now that's set y over here. We have this y up here now. Okay. All right. So now print out first line, go to sixth line. Sixth line goes to 3 line. 3 line goes to new line with parameters 1 and 42. So I went from here into here. Now, arg is the string 1, x is the string 42, and my y down here is this one up here. It's 1 million. Okay, so then I print out 0.1, x equals 42, y equals 1 million. Okay, and I keep, now I print out a different string. Now I print out a third string. That's 3 line is done. Now I have to do 3 line again. Okay, so I just do 3 line again, exact same thing again. Okay, so 3 line is done. So 6 line is done. So 6 line goes back to here. Okay, now here's the line that changes y. Now we'll see y change to 2000. Notice I put the underscore there to make it easier to read, but it doesn't show up over here. You're not, you can't control what the visualizer shows you up here, and it doesn't show a comma and it doesn't show an underscore. You can write your code with a underscore to make your numbers easier to read, but they don't, the variables don't actually hold the underscore. Okay, so now I've changed this y that's on the outside of my method. I changed this y that's up here. Notice that this y is the old value. See, that's my code. My code here, but I don't look over here for the value of y. I look over here for the value of y, because this is where the program is running. This started the value of y. That's what y started with, and it held that value for a while until I change it. But from now on, y is holding that 2000 value. Okay, so now I go here, I call 3 line again. So now I'm going to go back to 3 line. And now 3 line goes to 1 line. X is 1. No, I'm sorry. Arg is the string 1, X is 42, and Y is 2000 now. So when I print out this, I get this one is here, this one is here, and this one is up. Well, it's not, it's up here, but it's not that value anymore. Now, this Y is that one, but holding the changed value. Okay, so it's that one. This guy is that Y, but the changed value. So there's the printout. The printout was, I can't even, oh, let's see, can I fit it on the screen here? Yeah, there it fits, you can see a little bit better now. Okay. When I executed that line, I printed that line down there. X was this arg, which it shows me over here is quote 1 quote. X is this X, which it shows me over here is 42. And Y is this Y, which over here shows me now is 2000 because we changed the value of Y. So there's my values that go into this output. Okay. And then it printed out 0.1, X equals 42, Y equals 2000. Okay. All right. And then that's pretty much the end of the program. Oh no, actually I do three more new line. I do this. There's 3 line done. Okay. Now I print last line and the program's done. Okay. Okay, so that's what we talk about. That's what methods do. Methods store. You can think of a method as a way to store a bunch of code so that you could reuse it. So if you have a bunch of code and you want to use it over and over again, you can store it in a method. Or another way to think about it is you can give a name to a bunch of code. And you can also give that code parameters so that every time you use the code, it works a little bit differently. So you could use that code with different parameters to make it do different things. Okay. Now, these are what we call static methods. Now we're going to switch topics in our reading to something called object methods. So we're going to go from static methods to object methods. So we're going to see these sections here describe Java objects and how we call methods on objects. So we're going to switch from the idea of static methods. This was all about static methods to methods on objects. It's a kind of a big switch. It's kind of a big switch. It's a big jump, and it's really one of the core ideas in this course. This idea of objects on methods is one of the main ideas in all of Java and all of programming. Methods are important, but methods on objects are even more important. Okay, so we're going to switch from static methods to these objects and methods. Okay, so that's this. It's introduced in this reading. Okay. Let's see. Let me close this one. And do we need this one? I can close. Well, I'll leave that one there. So an object is an idea in computer science that's kind of tricky to explain. Okay, what it is, okay, let's just look at the code. Let's read this code. Okay. In this code, I have objects called world and objects called turtles. Okay. And if I run this, so what this does is it creates a world object and it creates a turtle object. See this notation here? That's a method. See, you have a name followed by parentheses. That's a method with no arguments. Okay. Oh, I shouldn't have closed that other window. See, we had methods with no arguments. See, we started with methods with no arguments. So you just put the name of the method and a pair of parentheses. That calls the method. Okay, so over here, that's what I have here. But notice it comes after the name of an object. See, over here, we called our methods just there. See, that's the name of the method. That's what we call a static method. You just use its name. So the method is a static method. You use it by just saying the name. Over here, we have a different kind of method. The method has a dot in front of it and the name of some object. In this case, it's Yertle the turtle. Okay. Now, in a minute, we'll run this. You'll see what it does. The idea is that a world is a piece of graph paper, and a turtle is a point on the graph paper that you can move around and draw things with. Okay. This is an idea that's been floating around for years. This is a way of teaching programming. A world is a piece of graph paper, essentially, and a turtle is a pen that you can move around on the graph paper. So you can tell the turtle to move forward. In this case, it actually moves forward 10 steps. And a step is just a certain distance. We'll see. Yeah, and this world is 300 steps long by 300 steps tall. So it's 300 steps wide by 300 steps high. And this thing moves by default 10 steps. Later, we'll put a parameter in there and say, I want you to move forward 50 steps. But right now, we're just going to do it with the no parameter, which defaults to 10 steps. You can make the turtle change his direction. So this tells the turtle to turn 90 degrees left, which means counterclockwise. Okay, left is counterclockwise, and he goes forward again. Okay, so watch, I'm going to run this. Okay, there's the graph paper that represents the world. Okay, sometimes they actually show it with like little grid, like it's a graph paper. So just think as a sheet of paper. It could be, just think as a sheet of paper where there's a turtle on it, and the turtle starts at the center of the paper, and this created the turtle. Okay, this created the world object. This created the turtle object. Then we called methods on the turtle object that said, turtle, go. The turtle starts at the center heading north. He went forward because we told him to. He turned left when he got here because we told him to. Then he went forward again because we told him to. Then we have to end this with the thing that says show the world. Otherwise, like if I comment that out and I run this again, it'll work, but it won't show anything. See, I don't see the result unless I end the program with world.show equals true. Okay, so that's kind of a weird thing. So I have to end this thing with so now if I want, I can add more methods here. I can tell the turtle to go right again, turn, well, let's say turn left again. Okay, now left means turn counterclockwise 90 degrees. So that'll actually make him point downward. And I can say, now we say that we're calling a method on an object. I'm calling the forward method on that object. Over here, we just called a method. We called a method. There wasn't any object. These are static methods. You just call them. Okay. Here, these are methods called on an object. And here I'm going to tell the turtle to go 40 steps. Okay. So now I can run this again. I've added steps to I've added more method calls on my turtle. So I have more steps to my program. Forward, turn left, forward, turn left. Oh, I thought the default was more than 40. I thought it was let's see. Looks like I moved about half of what I did before. So the default must be about 80 steps. I thought it was 20 or something like that. Let's try. Let's change this to 80. Maybe that's what the default one was, because it looks like I went about half of what I went before. So let's try this again. So I'm changing that to 80. There's the default forward. the default forward. Oh, not quite. Looks like it's maybe it's 100. Let's try this. Oh, and then I'll turn left again. That'll make him face east, and then I'll say go forward. Now, if this 100 is the same as how far it went up, he'll end up coming back and start ending where he was, where he'll end up where he started. So I'll just say forward here. Okay, let's see what this does. So run it. Go up, turn left, turn left, turn left again. See, end up back. So this forward, it was actually the same as forward 100. Okay. So for example, I could go forward 200. Okay, see, so we can control a turtle. You can do a lot with these turtles. If you kind of curious, we'll play around with this a little bit. But if you Google turtle graphics and click on images, you'll see all these pictures. That it's not hard to draw these pictures. You can get a turtle to draw that. You can get a turtle to draw that or that. You can get turtles to draw these things. It doesn't take very much code. Yeah, and that's one thing. We'll spend a little bit of time talking about this, but you can draw quite elaborate things just telling a turtle to move around. Okay, you can just by telling a turtle to move, just with simple commands like move forward, turn, you can make a turtle draw quite a few different kinds of pictures. Okay, we have to learn more about. We can't do that yet. Like we don't know enough Java to do any of these pictures yet. Yeah. So right now we don't have a way to draw any of those pictures, but as we learn more about Java, we can go back to the turtle and have it do more and more elaborate things. By the end of the semester, we'll know enough about Java to draw any of these pictures. Okay. To draw uh, any of these pictures, we could draw them by the end of the semester. Okay. And Turtle Graphics works with any language. See, there's JavaScript versions of Turtle Graphics, Java versions of Turtle Graphics, Scratch versions of Turtle Graphics. There's versions of Turtle Graphics in all these different kinds of programming languages. Okay, so now this version of Turtle Graphics is Turtle Graphics is not part of Java. So for example, we cannot do Turtle Graphics in the Java Visualizer. The Java Visualizer, if I take this code and put it in the Java Visualizer, the Java Visualizer is going to say, I don't have a clue what turtles are. It has no idea what anything about turtles mean. It does not know what a world is or a turtle, because worlds and turtle are not part of Java. They were written for this book. Okay, so it was code. So the people who wrote this book wrote the code for this forward method. Remember, like print line, when we do things like this, when you call that, somebody wrote that. Oh, notice that's a method on an object. See, there's the dot there. We haven't talked about it yet, but this is actually a method on an object. Now, that was written by the people who wrote Java. So you get that method with Java. We wrote these other methods, okay, but printline was written by the people who wrote Java. When you get to this book, the turtle stuff was written by the people who wrote this book. They wrote the code for the turtle. Now, you can do this in the Java Visualizer. You can do this in Dr. Java, because I added the turtle code to Dr. Java. Okay, so let me Okay, there's my turtle code. I can save it. I can compile it. Okay, we got a little warning here. You know, I see if I can remember how to get. Okay, I get a little warning here. Don't worry about that. Let's see. Now run it. See, there's my turtle. Notice it didn't do the fancy thing of going up, turn left. It didn't animate it. When I run this thing in Dr. Java, I don't get the fancy animation, but there's my turtle. Okay, so I can go back here and I could continue on adding code. Like I can tell Yertle to turn left again. And I'll tell Yertle to go back where he started by going another forward 100. That'll take him back to where he started. So I compile it. Okay. Oh, I misspelled Yertle. Okay. Run it again. So he started there and he went forward, turned left, then he went forward 200, turned left, then he went forward 100 and ended up back in the middle there. Okay, so the Turtle graphics works in Dr. Java. Now, if you're on a Mac, oh, no, excuse me. This only works if you use Dr. Java the way I gave it to you. That's one of the reasons why I gave you that CS123 folder at the beginning of the semester. I gave you that folder with Turtle graphics built into it. Okay, if you go to that folder, I put the Turtle graphics in this subfolder. See, there's the Turtle graphics. Okay, so that's the Turtle graphics stuff. It's in that thing there. Okay, so I put that in this folder. Oh, and the other thing in that folder is the thing that gives you the light and dark mode. There's the thing that gives you, there's the thing that creates the dark mode. There's the thing that creates the light mode. If you, I don't know if you can open these things in. No, if you open them like in Notepad, well, this is what it looks like inside of them. So it's like a special kind of code. It's a code that programs Dr. Java. We programmers write code for everything. So almost everything we work with has code behind it that lets us say things about it. So this is essentially code that tells Dr. Java how I want it to work. Right there was the thing where I told it about the Turtle graphics. Okay, so there's where it told Dr. Java, I want you to use Turtle graphics. Okay, now if you're on a Mac, this may not be working, but I can show you probably what will make it work. Okay, in Dr. Java, and even if you're on Windows, you may have to do this. If you go to the file, go to Edit, Preferences, open the Preferences window. Now on a Windows machine, Preferences is under Edit. On a Mac, Preferences is up on your upper left corner on the title bar. Okay, you go to Preferences, and then you click, see there's this Resource Locations. See that line there? It should say Turtle Graphics in it. If it doesn't say exactly that, see it should point at the Turtle graphics in the CS123 folder. If it doesn't, you could add something. You could go, you click on add, and add lets you go, you can find the Turtle graphics thing where it is on your computer. So in my case, it's under the C drive in CS123 folder in the config file, there's Turtle graphics. Okay, so if it's not working on your Dr. Java, you probably need to change what's in this guy here. So again, that was on Windows, it's Edit, Preferences. On a Mac, the Preferences items in a different menu. And then you want the resource location right at the top of the here's where you turn on line numbers. See, there's where you turn on line numbers. It's under resource locations. It's this middle bar here. If I click that X and eliminate this, I lose access to the Turtle graphics. So if I X that out, it would disappear, and then I wouldn't have, I could put it back, but then I'd lose access to the turtle graphics. Okay. So that's how you would get turtle graphics working in Dr. Java. Okay. So this code up here creates objects. This is how you create an object. Like I'll create a second turtle. I have a variable of type turtle. I'll just call him T2 because it's a lot easier to type T2 than Yertle turtle, whatever. Okay, so I'm creating a variable. This variable is my turtle. But then I have to tell Java that I need a new turtle now. And that turtle is supposed to live in this world. Okay. So now I've got two turtles. So now I could tell each turtle what to do. I can go down here and say T2 dot, instead of a turning left, I'll make him turn right. And I'll say T2 dot forward 200. And then T2 dot turn left. Okay, so now I've had my other turtle. I can compile this. Okay, run it. The second turtle has a different color. Now the second turtle started off by, you notice I ended up pushing him all the way to the edge of the screen. So I pushed. If I pushed him anymore, he would just go off the screen and disappear. But he started over here. He was heading. He always starts heading north. He turned right. So he was facing east. Then he moved forward 200. Okay, and you can't tell it, but he turned left. So he's actually, you can just barely see it. He's pointed north. So if I go here and make him move a little bit less, okay, compile, run. Well, make him move a little bit less. Let's see. Didn't seem to change. There, okay. I don't know why. I wasn't moving him back enough. Okay, so you notice he turned right, moved forward 100, then turned left, and so he's facing north again. Okay, notice when you create new turtles, they get a different color, so you can tell them apart. So the first turtle was by default greenish. The second turtle is bluish. Okay, all right. The key thing is that I can call methods on my turtles. Okay, I can have more than one turtle variable. I have to create the turtle objects. We say that this is creating a turtle object. Each turtle remembers things about himself. So each turtle, when you give it a command like this, the turtle remembers that it's changed direction. Then when you make, I'm sorry, the turtle remembers that it's moved positions. Then the turtle remembers that it's changed direction. Then the turtle remembers, so it does the motion of this command, and then it remembers where it is. Okay. Okay. So this is what we call object-oriented programming. Okay. This style of code is what's referred to as object-oriented programming. Okay. And that's what we'll be talking about for a while. Okay. Now let's see. We've kind of run out of time at this point. Okay. So this is the introduction to turtles. Okay. So this one here introduces turtles. Now if we go back here, the next thing we're going to do is we'll do it on Tuesday, is we're going to talk about another kind of object, string objects. So here we were talking about I'm sorry, down here. Here we were talking about turtle objects. Okay. And we're next we're going to talk, here's some more, we'll go through this code real quick. These are more examples of what we were talking about, creating and initializing objects. See, we created more than one turtle. So when we created more than one turtle, we were doing this section here. Okay, we were calling methods with and without parameters. See, some of our methods were with parameters, and some of our methods were without parameters. So we've talked about most of what's in these sections here. We use this code to talk about creating objects, calling methods with parameters, calling methods without parameters. On Tuesday, we'll do a little bit more of this, and then we'll talk about what's called string objects. Besides turtle objects, we can also talk about string objects. String objects are the strings like hello world and stuff like that. Java is an object-oriented programming language. Almost everything you do in Java involves objects. Okay, so we'll talk about, we read these sections, play around with the turtle code, try using the turtle code in Dr. Java, and then we'll talk about a little bit more about turtle code on Tuesday, and we'll start talking about the string objects. Okay, so gone over a little bit, so we're done. Anybody have a question about what we did today? Any question? Try to get the turtle code to work in your version of Dr. Java. If it doesn't work in your version of Dr. Java, ask a question about it. So you should be able to get the turtle code to work in Dr. Java. Okay, you should be able to get that to work in Dr. Java. Again, remember, you may have to go through, you may need to go and make that change there, but hopefully you don't. Hopefully it's set up right. Okay, any question? Okay, so if you have questions about the new homework assignment, ask. I have office hours this afternoon. Excuse me. And okay, we'll go ahead and quit now. So have a nice weekend, and we'll meet again on Tuesday. Goodbye.